Hello, hi people, happy pi approximation day. So what is so special with today's date? It's 22/7. So usually we have two dates in a year's calendar. We have two dates which are relevant to pi. We can link them with pi. One is March 14. We call that to be pi day because the date is 3.14. So month 3 is for the month, 14 is for the date, 3.14. It's called the pi day. And this is 22/7, 22nd July is celebrated as pi approximation day. Right, that fraction, it's an approximate value, and hence it is called pi approximation day, which is today. As usual, like every other occasions, we try to link any of them with math. So here also we are going to do some math work. Pi or 22/7, which is going to be bigger? Pi is irrational, we know that. 22/7 is a fraction, but while comparing who is going to be bigger, we are going to see a concrete proof. Who is going to be bigger, who is lesser? Right, yes. Here we are going to have a simple proof for, I won't say very simple, it's going to involve some complex ideas. It's going to involve, we are going to take the help of calculus to prove this. We are going to prove that pi is going to be less than 22/7. I am going to take the help of integral calculus. So for which I have taken this function, it looks strange. X power 4 into 1 minus x the whole power 4 by 1 plus x square. Actually we are going to integrate this from 0 to 1. So what happens when you integrate? When you integrate, you will be getting the area covered by that curve with x-axis, under x-axis. This is what we will be getting. And here we are integrating from 0 to 1. So this becomes a definite integral. Let's examine something about that integral. Fine, yes. X-axis, y-axis, this is x is equal to 0. Let's see what happens to the function when x is 0. When x is 0, things are simple. This entire thing becomes 0. 0 into anything, it becomes 0. And similarly, when x is 1 also, when x is 1, then also what happens is, here this part 1 power 4, but this one becomes 1 minus 1, that becomes 0, making the entire thing 0. But what do you think about values between 0 to 1? When I put any other value for x between 0 to 1, what happens to this function? This is going to be positive, this is also positive, 1 minus x is positive, this is also positive. So very clear, this curve will be something like this. And hence, after integrating, the area what we get will be this. Definitely that is going to be positive, meaning this is going to be greater than 0 or 0 is less than this area. So this is the starting point for us to continue this problem. Let us continue and see what happens. Something interesting, we'll see what happens. Let me clear up this. Okay, yes. So here we start like this, integral 0 to 1. This is x power 4. Let us expand that 1 minus x the whole power 4 using binomial theorem. So we'll be getting 1 power 4 1 minus 4c1, 4c1 is 4 into x, plus we will get plus minus alternatively. So plus minus, next is plus 4c2 which is 6 x square minus 4c3 4 x cube plus 4c4 which is again 1 x power 4. The whole divided by, this is 1 plus x square into dx. Nice, fantastic, we have expanded this. That means 0 is less than integral 0 to 1. Now we will distribute this x power 4 inside, we will multiply that. So I am going to write it in the descending order. So we will happen to get x power 4 into x power 4, x power 8. Then we will get minus 4 x power 7 plus 6 x power 6 minus 4 x power 5 plus x power 4. I hope it is clear. So I am multiplying this with this, x power 8, this with this, minus 4 x power 7 and so on, descending order. Denominator 1 plus x square, which is x square plus 1 dx. All fine, good. Now is a bit challenging. We need to expand this or we need to divide this because this is a polynomial with a higher degree. Its degree is 8. Here we have another polynomial whose degree is 2. So why can't we divide this? We will divide and try to simplify this expression. So I am going to divide this separately, not to confuse here. We will divide this, do this division separately. So I have taken down this polynomial separately, x power 8 minus 4 x power 7 plus 6 x power 6 minus 4 x power 5 plus x power 4. Done. Yeah, ready here. So this we will divide it by x square plus 1 because that's our denominator. Right? We will do this carefully, patiently. So I can start with x power 6, x square into x power 6. This will be x power 8, then plus x power 6. Alright. Now I can subtract it. When I subtract, this goes off. When I subtract here, I will be getting we'll be getting like 5x power 6. Okay, all right, this is good. Then I can drop this one here, minus 4x power 7 plus, and this also minus 4x power 5. Let's see what happens. Okay, what about the next term I can add here? So x square, I have minus 4x power 7, so that means I can multiply with minus 4x power 5. This looks good because every time we'll try to eliminate the higher degree. That's why we are doing this. So going back to the school days, so here we have minus 4x power 7, then this into this will be minus 4x power 5. Great. Okay, done. Then we can drop something else. So this minus this also plus this gets subtracted. Fine, good. Now we are left with this one, 5x power 6, and luckily this last one plus x power 4. Now that we can multiply by what? Here x square, here 5x power 6. So I can multiply this with plus 5x to the power 4. Good. X square into 5x power 4 will give you 5x power 6. So multiply 5x power 6. 1 into 5x power 4. This will be plus 5x power 4. Okay, great. Done. Now that again I can subtract. This goes off. I can subtract. Here I will get minus 4x power 4. Is there anything left? That's it. We have dropped everything. We have dropped everything. Finally, again we have to take the remainder. So what next I can do? One last step I can perform. This is minus 4x power 4. Here I have x square. I can multiply this with minus 4x square to obtain this term. Minus 4x power 4. Then minus 4x minus 4x square. So I'm just looking at the terms because so many terms are there. That's why. So we'll check this. So minus 4x power 4 minus 4x square. Brilliant. Nice. Goes off. And here if we subtract, we'll be getting 4x square. Finally, right? Yes. So this is all we are getting, correct? Done, 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 done. Yes. So we have dropped everything, right? We have dropped all the terms and everything. Done, done, done. So far it is going to be clear. So we'll think of what can be done next. So we will try to write this one now separately. Okay, yes. Again, continuing this, we can do one last step. So this is x square, this is 4x square. Can just do plus. So I can do plus 4 plus 4x square plus 4. So now that I can do the last step, it goes very long. So we are finishing here. So minus, this goes minus 4. Success. So this is all we are left with. So finally, this is our quotient. And here we have our remainder. So let's get them to our first initial, that place. So we'll be having x power 6 minus 4x power 5. I'm going to copy down there. X power 6 minus 4x power 5. Okay, we'll be getting x power 6 minus 4x power 5. I'll check this. Yeah, plus 5x power 4 minus 4x square. Plus 5x power 4 minus 4x square. Then what else we have? We have plus 4. So plus 4. That's it. This is going to be our quotient. Then what else are we having? We have minus 4. That's our remainder. So minus 4 by this. Minus 4 by x square plus 1 or 1 plus x square. Minus 4 by 1 plus x square. Finished. Done. So this is what we have. Yes. So what are we doing? We are dividing this by this quotient. This is going to be a remainder by the divisor. That's it. Finished. Success. We have ended up here. Now 0 less than. Now we have to integrate. You will have to use the integral. Again 0 to 1. So integral 0 to 1. Or we can straight away also integrate, because we are knowing all the values. We can straight away integrate this. So once we integrate, we will be getting x power 7 by 7, because this is x power n. X power n, if you integrate, you will be getting x power n plus 1 by n plus 1, which is what I am doing here. And next minus, this will become 4x power 6 by 6. This becomes 5x power 5 by 5, or x power 5. And this will become minus 4x cube by 3. And this will become plus 4x. And finally, minus, this is 4 of integral of dx by 1 plus x square. It's going to be tan inverse x. Tan inverse of x. Success. That's all. We have completed integrating everything. Now we have to apply the limits 0 to 1. Hereafter the process is going to be simple. We have just crossed all the complicated steps. Now that we need to substitute the limits and then simplify the answer. Let's see what's going to happen. Fine. Yes. say 0 less than. Now 1, we'll make everything, all the numerators to be 1. So this is 1, 1, 1, 1, 1, every x bar term will become 1. So this is 1 by 7, 1 by 7, I'll straight away substitute the values. Minus 4 by 6, or it's going to be minus 2 by 3. This is plus 1, minus 4 by 3, minus 4 by 3, plus 4, so plus 4, and then last minus 4 times of, what about tan inverse x? So tan inverse x, we have to substitute the limit. Tan inverse 1 is going to be, in terms of degrees, 45 degrees. Radians is how we have to get the answer. It's going to be pi by 4. So it's going to be pi by 4. So pi by 4. What do you think about substituting the lower limit 0? All we have done there is substituting the upper limit. Everything we got that expression. Now taking x is 0 will make the entire thing 0. Every term will become 0. That means answer should be this entire thing minus 0. 0. Yes. 0 less than. Now all we need to do is simplify this. So we will be getting 1 by 7. This is plus 1 plus 4 plus 5. This is minus 2 by 3 minus 4 by 3. Minus 6 by 3 is minus 2. Minus this is going to be pi. And interestingly this is going to be 0 less than. This is 5 minus 2 is 3. 3 plus 1 by 7 is 22 by 7 minus pi. Or it will say that pi is less than 22 by 7. Yes. Success. With a long struggle we have done this. Yes. Pi is actually lesser than 22 by 7. So why do we struggle all this? We take a proper nice integral for us to infer this. So it's a complicated yet an interesting proof, a concrete proof for us to realize that pi is less than 22 by 7. Hope this kind of math travel makes us feel more enjoyed. So live with mathematics, enjoy mathematics. So yes, happy pi approximation day once again. Thank you so much.